And it's good old absolute value. This could have been taken straight out of Chapter 1, Algebra 2. Shouldn't take us too long. Anyone need more time? Going once? Going twice? Sold to the person in the front row who accidentally had an overactive bladder at the inopportune moment. Suppose y'all too young for that one, right? There's a gal who was like getting up to go to the bathroom in the middle of this big like art auction like 10 years ago or something. She accidentally bought like a $2 million painting. No? It was a thing. It was a meme for a while. All right, that one's gone. That one's gone. Gone. Got everyone else? Cool. Folk. All right. Transformations. We absolutely beat them to death in Algebra 2, so this should not be too big a deal. We have y is a times the function of b by x minus h plus k, where f of x is your parent function, and a, b, h, and k are going to do the same business no matter what that parent function was. A, vertical stretch and compression. Stretch is greater than 1, compression is less than 1. If it's negative, a vertical reflection or reflection on the x-axis, depends when you say it. B, all that stuff, but bass-ackwards. It's horizontal, and now you're talking about the reciprocal. H, horizontal translation. Again, it's grouped in with x, bass-ackwards. If they say -5, you're going right 5. And K, if it's off to outside of that grouping, that is a vertical translation, regular town. So we start by identifying who is your mathematical daddy. Parent function. Absolute value of x. We call it the parent function because it's the simplest that it ever gets. Like, that is the progenitor of all other absolute value functions. The things that happen to it, there are 4. A couple of kids whip their heads at their paper like, oh no, did I write 3? Did you fall into the trap? That this has 2 different transformations. They're just both in the A spot. We have a vertical reflection or reflection in the x-axis. We take either if we do it first. We have a vertical stretch or compression. Ooh, I heard both. Fight! Stretch because it's greater than 1. Remember, the negative is, yes, it is in the A spot, but it's the absolute value of A less than or greater than 1. Okay, so vertical stretch, and we really pound on that in Algebra 2. Y'all, now that we're big kids, as long as we understand the difference between stretch and compression and what creates them, you can just say dilation by 3, dilation by 1/3. Just like your pupils depending on which section of the parking lot you go to at lunch, will dilate either bigger or smaller. Okay? And a horizontal translation, we're going to go left 4, and a vertical translation, up 6. So we have the parent function and 4 different things that happen to it. The translations determine where my, translations determine where my vertex goes. Normally it's at 0, 0 origin. I'm going to go left 4, up 6. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And if you remember from the ancient times, the vertex of an absolute value is always at hk. The slope on the right-hand side is always going to be a times b, the combination of your vertical and horizontal dilations. So -3 times 1 is -3. From my vertex, I go down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1. Because it's symmetrical, about an axis of symmetry, if it's 1 to the right, 1 to the left, 2 to the right, 2 to the left, 3 to the right, 3 to the left, or I can also go down 3, left 1, over and over. Yeah. I'm going to assume the best for you, that you have the parent function on there. What I'm looking for are, do you have your 4 transformations and the graph? I'm only going to do one for the graph. It's either right or wrong, because you couldn't just dump that in your calculator and plot points. Okay? So, 5 things all together. Yes, ma'am. Math abs. And it's also a shortcut under our alpha, not y equals alpha window? Yeah. Alpha window has the most commonly used functions, and also depends on what calculator you're on. We found that, like this, TI-84 Plus, it doesn't have it at all. It does have alpha shortcuts, but it doesn't have that. It's when they went to the TI-84 Plus Silver. Now all of a sudden they had all that extra stuff. The whole lot of you have, what is it? Plus C Silver. So now it's color screen and it's got that stuff. So you're good to go. Okay. Like they slowly started upgrading things, but yes, alpha window on the C models or better will have that as a shortcut. Otherwise, math abs. Yep. Oh yes, close that parenthesis if you, because if I do it on this calculator, it's going to put the absolute value brackets in there for me and I just arrow around on it. But if I'm doing it on an older model calculator, it'll say abs parenthesis. You have to close the parenthesis when you're done with absolute value. Otherwise, it'll just jam it all in there. Okay. The homie work. What do we think? I didn't have anyone ask. So I assume we either decided we didn't have to do it or we're good. Make choices. When you go into our shared folder.
Well, I looked under the 1.5 and it was not the right thing.
Oh, no. Remember that I'm using the old section notes. The page that this assignment was from was section 1, 2, or 1, 3 in the new book. So you look in those ones. Yeah. Remember the chapters 0, 1, and 2 between the new curriculum and the old curriculum, they're just scrambled eggs. They're all over the place. So we can still have assignments from the book. It's still the same content, it's just the order is a little bit different. So always pay attention to what page and section you're on in the book if you're looking for solutions. Oh, that's right, I was ADHD go brrr. We want the calculator on the other page. All right. So while Frank is trying to think of what a calculator looks like, here you go. Review.
I understand 9, but
I love having a whole table to myself. Thank you. Shows that nobody else does. Yeah.
I mean,
because I can didn't pay attention during the video.
like right now, you got about half the kids in the room are doing the little monkey puppet meme, right? Ah, there's my calculator. Right? Isn't it from like Muppets or something? Not Muppets. What is that from? The little monkey that's always looking sideways.
No, but I know what you're talking about. It's not Toy Story. Actually, maybe I can. Let me look it up. Yeah.
There we go. Okay, you go away, you go away, you come here. Yes.
But I don't know where it's from. Do you know what this one is for? No.
Okay.
What are we doing?
Review. We left off at the end of 1-2. Was symmetry and odd-even functions. I think we had gotten to it before our last test, but like barely, and I didn't want to put it on the last test. So here it is. Symmetry of the function, whether it's odd, even, or neither, justify numerically and prove algebraically. Step 1. If you don't know what that graph looks like, so you know what type of symmetry and all that you're supposed to be looking at, you best dump it in your calculator and see what it looks like. Okay, so we go to y equals, clear, 1 over x to the third. I'm also going to do 1 divided by x to the third, just so y'all see the difference between written as fraction, written as decimal, depending how you put it on there. Graph. Well, that graph looked weird because this is still on our flamethrower candle from the other day. So I need to zoom, standard. Yeah, wouldn't y'all have like a 20-inch radius or something like that? Okay. Yes, ma'am.
How? This is what my calculator did.
1 over.
Oh, I didn't minus.
Okay. All right. So I look at it and I say, what kind of symmetry do I think it has? Origin. Because take your calculator, flip it upside down. Looks like the exact same thing. Okay? So if I think it looks like origin, then that's the test that I'm going to run. You don't need to run symmetric to the y-axis because it doesn't look like it. Don't run x-axis, it doesn't look like it. And the test is, I'm going to 2-for-1 here. I'm going to do the, okay. Now I'll do it both so you see the difference. If I'm proving symmetry, you would say y equals 1 over x to the third, and then what is the rule for that? Negate both. Okay, make sure you have those rules written down. So I'm going to put in a negative y and a negative x. I get a negative y. I get a negative 1 over x cubed. And if I divide both sides by -1, I end up right back at where I started proving algebraically that it is symmetric to the origin. Now, if you're already going to be showing whether it's odd, even, or neither, I wouldn't actually do it this way at all, because how do I show it's odd? Very, very similar, but I'm in function notation, right? To show that it's odd, I would negate the entire thing, which is negating the y value because it's the output, and I would negate the x, which gets me a negative f of x. Oh, sorry, negative f of negative x, because I'm negating both, is 1 over x cubed negative. So I negate the function, I negate the x. I simplify this one, and just like over here, I got negatives on both sides. So I get f of negative x is 1 over x cubed. The last stage to it, see how all of this looks almost identical, right? It looks almost identical because of that whole duality between you have function notation versus its related equation. I can just go one more step and only do this. I would say negative f of negative x was regular f of x, because that was the definition for the proof of odd, right? I negated the whole thing and I negated x, and I ended up right back where I started. That last line is the proof for it being odd. But because I can substitute in y for f of x and f of x for y, respectively, what I'm telling you is you don't need to do this part if you do this, because you are still showing the same thing algebraically. Okay? Now I do need to find a point on this graph so that I can show that symmetry numerically. Remember, it says prove algebraically, support numerically. So how do I find a point on this coordinate? Point on this coordinate. A coordinate on this graph. There we go. Pick a number, throw it in for x, see what we get. 3? Okay. So Jacob says he's going to put in 3. F of 3 is 1 over 3 cubed. So if I put in a 3, I'd say f of 3 is 1/27th. I have shown that 3 1/27th is on my graph. Kind of wishing you'd said 1, aren't you? It don't matter. It's going to be the same thing, right? It's not hard. Don't be afraid of fractions. Okay, I've shown that this is on my graph. Now how do I support that origin symmetry? Negate both, just like I did x and y over here. So now I'm going to say if I negate both, I should be able to put in a negative 3, and I'll get out a negative 1/27th. And sure enough, I get negative 1 over 27. So the point negative 3, negative 1/27th is on my graph. Okay. Again, getting you ready for the big leagues where most of your classes prove. Okay. So again, you don't have to do this and this, prove symmetry and prove that it's odd, because if you're proving that it's odd, you are proving the symmetry. Okay? Don't save yourself time. Oh, you should probably actually write odd next to it in symmetric to origin. I didn't do that, oops. All right. Determine the continuity of the function. Identify any points of discontinuity justified with the continuity test. That said continuity 3 times in one set of directions.
Oh my goodness.
Oh, discontinuity. Oops. So, which continuity? Discontinuity. You know what that graph looks like? If you don't, sketch the graph. Put this in y1, y2. Okay, so this guy looking like this. We did this last semester, remember? The 83s show vertical asymptotes as a line. Okay, that's what that entire function looks like. That's what that function looks like. But I don't care about them in all locations because it's a piecewise function. Y is clear. X minus 1. Whoop. Clear. 1 over x minus 3. Yeah. Okay, graph. I suppose I had my colors backwards. Whatever. And where do I or do I not care about this? Okay, you look back at your rule. Your rule says I'm going to follow the line when x is greater than 4. So I can trace the line out to 4. Well, and I say I'm going to start here and follow that line. Okay. And I'm going to follow this one. Okay, that's just going to bother me now. I'm going to follow this one only when x is less than 4. So I go to where it hits 4, and I'll follow this guy. There's a method to the madness. Right? Because I can cheat and you can't. Ha. Instead of me putting the black marker on there, like, only took me about 15 years to think, hey, I should just do that. Then it's not a function if it's in both places. So you double check the rules about when it equals and when it doesn't equal. And now, Jacob. Okay. That's close enough. All right, so there's a graph. You have to figure out where this thing is discontinuous. It doesn't say test at these numbers anymore. We're big kids now. You're going to say, where is there any point of discontinuity? Well, we have 3 kinds. We have infinite discontinuity, which occurs where? Vertical asymptotes. So does this thing have a vertical asymptote? What number am I testing? So I will say there is infinite discontinuity at x equals 3, but then I have to have the test to prove it. Okay. The test is 3 parts. Function of, put in a 3 into the original. What happens? Which of the 2 rules do you follow? Here. Which of the 2 rules do I follow when I plug in 3? Bottom one, right? So when I plug in 3, I get 1 over 0. 1 over 0, no binos. Then, limit. Limit of my function as x gets really close to 3. Now for that one, you might be able to use your eyeballs. If not, get in your calculator, and you're going to go to that ask feature, or you're going to trace on this screen, and you're going to go to 2.99999, and you're going to go to 3.0001. You get really, really close to it and find out this guy's going to negative infinity, that guy's going to positive infinity. So what's my limit? There is none. And then oddly enough, undefined equal undefined, I still have kids try to say that that means it checks out. Like, no. Because undefined isn't actually a number. You can't say nothing equals nothing because that nothing is not defined. Like, equality must have a definition. So, you could just say this by looking at it, right? You justify with the continuity test, but you should just know, looking at this function, oh, hey, I'm going to have an asymptote at 3. That means there's going to be infinite discontinuity at 3. And after this quiz, that's what we're going to do, like forever. You're just going to tell me, okay? You won't have to prove it anymore. Just like in geometry, once you proved that a linear pair was 180, you never had to do that again. You would just say definition of linear pair, okay? We also have removable discontinuity. When does that happen? There's a hole, and the hole is caused by canceling out factors. So look at your function. Did I cancel factors at any point? Doing all right there, bud? Okay. Just get the image of like the 3 of you shopping through the Safeway bakery section at 7:30 in the morning. Okay. But I do have now the other one. The third type of discontinuity is jump. Jump only occurs on piecewise functions, and it only occurs if you jump from one rule to the other. Be careful. What if this had started here? Right? It would have been continuous. Find the hole there. Okay. So just be careful about it. But it appears to jump from one rule to the other, so I'm going to say that there is jump discontinuity at x is what? And I'll test. Function of 4. Do I put it in the first rule or the second rule? Second rule, right? Because it says or equal to. Plug in a 4, I get 1 over 4 minus 3, which is 1. It exists. Yay. But then I go to find the limit. And again, whether you're looking at the table in your calculator, or you're tracing on the calculator, or you just eyeballing it because you got the sketched graph, as this guy goes to 4, it's getting very close to 1. As this guy goes to 4, it's getting very close to 3. They're close, but they are not the same thing. So, limit does not exist. And 1 does not equal empty set. So it fails this guy and fails this guy. Again, this stuff down here is what I need to see on your paper. Couldn't you do every bit of that just in your calculator? Okay. Now be aware, I am looking for specific things, like a really common one that kids goof is when there's a hole. Remember, if there's a hole, the limit does exist. It's wherever that hole was Thanos snapped out of there. Okay? Holes do have limits because you're approaching the value. It doesn't have to equal the value. Make sure you write out all parts. Make sure what? When you say infinite jump or removable, make sure that you say where it happens, so I know exactly where you tested. Little things. You don't want to get caught, not doing the little thing. Like, there's 3 of you between the 2 classes who turned in a paper or the Chapter 0 packet. Y'all, second rule of kindergarten. Put your name on your paper. Like, don't bite anyone.
I was not the child that did it. I was the child that used pen on his homework and got yelled at.
Okay, round 3. Locate the extrema, state the intervals in which it is increasing, decreasing, and constant. Those 2 are related, right? Because by definition, extrema happen when it goes from increase to decrease or vice versa. So first thing I got to do, dump it in my calculator. I'll say x to the 4th plus x to the 3rd minus 3x squared minus 5x minus 2. And I would write a note next to this so you don't get caught in the trap. Find it. Find it for real. Don't estimate. If it's a terminating or repeating decimal, we can write it as a fraction. If it's not, how many places are we going out? All right. So I put that in. I graph I just pulled random polynomials off of stuff too. I have no idea what these are going to look like. Okay. Careful. How many extrema does this have?
Looks like 1.
What is that called again? It is not constant there either. We specifically talked about this point of inflection, remember? I'm coming in on North 85. I see a cop in the median. I hit the brakes. I let off the brake. I'm still decelerating. I let off the brake because I think maybe it's one of those city trucks. Changed, but it was still decreasing. If you're not sure, you can always zoom in on that area because how do I know it doesn't have a little wiggle to it, right? There might be tiny, tiny extrema there. Like if I saw that, right? If I zoomed in enough and I just saw these extrema that were 1/100th of a unit off of the axis. So no harm in zooming in and double checking. But yes, there is only the one. Someone in here has already pressed the buttons. Where is it? Five, four, who? Someone else going to confirm that for me? I don't know if we trust what Jacob's saying. Okay. All right. And what kind of extrema is that? How do I know it's absolute instead of relative? The lowest that the graph ever goes. So we'll say that there's a absolute minimum, and I'll put that as approximate. Y'all, I just pulled polynomials out of random textbook problems over the years. I got a test bank of like 15 of these different forms. So I don't know what it's going to be. You might have one extrema like this. You might have 5. Probably not 5. I think the highest I ever go on these is quartics. So the most you should have is 3. Be careful about that point of inflection. We specifically talked about that in class. Those are not extrema. It's just, it is a point of inflection. It's a point at which the rate changes. Move on to the next one, right? I found my extrema. Read the directions. Tell me the intervals of increase, decrease, or constant. And this thing increases here to here and decreases all the way through that point of inflection to there. So make sure you state that this increases from about 1.250 to infinity. It decreases from negative infinity to about 1.250. And remember, these should relatively line up. It should look like a number line when you put all of those intervals together. Remember the increase-decrease thing? Some of us went cross-eyed on this because of, on the left-hand side, it looks like the graph is going up, right? Intervals of increase and decrease are as I go left to right. As I go across the graph this way, what is it doing? And the easiest way I could get that done is to actually put my pencil on the paper and trace it from left to right. My pencil is going down until I hit this point, decreasing. My pencil is going up, increasing. Okay, left to right like a book. Honestly, I think every form of the test that I've ever had, I put a polynomial here. I don't think I'll have a piecewise function there, but if you have a piecewise function, the possibility for constant exists because you just have like y equals 4 and it just goes straight across. Average rate of change. What is average rate of change? Fancy, fancy, fancy words for find the slope of the line through this interval. This is not a coordinate. These are the x's on my interval. So, teenagers, full of drama. If you have an x, you better find out why. Go plug in 1. I just like saying it in class because you'll get a couple of kids be like throwing their friend under the bus. So, okay, so I plug in a 1, I get 1 minus 7 minus 4 is a negative 10. I plug in a 3. I get 27 minus 21 is 6. 6 minus 4 is 2. Y'all, last 48 hours or 36 hours have been interesting. Check my mental math.
That is correct.
Okay. Remember, the easiest way to do this is dump it into y1, and it just straight up gives you the coordinates. Sorry about the squeak there. X to the third minus 7x minus 4. If I go to my table settings, switch my independent over to ask, and go into my table, I can just type in 1 and 3, and they just give me the coordinates because those are the function values. Okay? I know you can do all that in your calculator. I know you can do this by calculator and mental math. What I would like you to have at the minimum, so I can give you partial credit if you do a goof, is write this part out. Okay? Because if you're putting these values in and you're showing me where you're putting them, I can at least give you partial credit if, look, you got the right numbers. You just swapped X and Y like you're, 8th grade again. Okay? It happens. I'd still give you the partial for it. Okay? So I'm going to say my coordinates here are 1, -10, and 3, 2, which are x sub 1, function of x sub 1, x sub 2, function of x sub 2. So I'm plugging in 2 minus -10 over 3 minus 1. Now someone's going to ask if I can swap those around. You can, but you got to remember to do it the same way. My Algebra 1 classes, we always said, like, no crossfire. Meaning, if I said 2 minus -10, I have to say 3 minus 1. So you're firing in the same direction. Because anyone who's ever enabled friendly fire knows, if you go the other direction, bro! Good! Rage quit! Okay? If you have crossfire, you have screwed up the problem. You're now going to have the sign as bass-ackwards. Okay? So, we end up with a 12 over 3. No, 2 is 6. That was close. So, at the very least, I want to see this so I can still give you partial credit if you do a goof. Okay? Yeah, it's just find the average rate and change. Nice and easy. Well, some of the problems are a little more involved than others. Okay, and just like our daily check in yesterday's assignment, who is thy mathematical parental? What's parent function? X cubed. Okay. Yo, look at that very first page of 1.5 where it had those, what was it, like 8 or 9 different types of functions. It's going to be one of those. Okay? So I state f of x is x cubed. It looks like a cubic. It ain't going to be weird. I'm not going to go up to x to the 5th or x to the 4th or anything like that. It's going to be one of those parent functions on that page. But then you got to tell me what happened. Well, normally a cubic starts here. I went and I moved translation to get my point of inflection is over here. So I would say, use your big kid words. Don't you dare say left 2, down 3. Big kid words. Now you can abbreviate, that's fine, but use your big kid words. Because man, would that suck if you were doing a final and it said horizontal translation down 2, vertical translation left 3. Okay, at everyone in here who took the Algebra 2 final. Okay. Grumble, grumble, grumble. I got my 91.8. I don't have an A because you got caught in the words. Okay, you got caught in the words. What else happened to it? Okay. Now we're going to find out who actually did the lesson video, who actually went through it, hopefully, because I'm pretty sure I say this every year. What do I say now that I've already translated? I just say a vertical reflection. If I said reflect across the x-axis now, after already having translated, where would it go? It'd go up top, because I'd be taking something down in quadrant 3 and reflecting across the x-axis. Okay, you probably remember that from geometry, moving those triangles around, right? If you translated then reflected versus reflected then translated, that's a different thing. Okay, so because I've already said my translations, I'm now going to say vertical reflection. Does it have a stretch or a compression to it? How do I know? Now we find out who went and watched the other 7 minutes of the next video.
I don't know if I'm right.
Well, I can't hear you. Okay, the cube steps, I'm looking for what it should have done over what it did do. Okay, as a percent change. So normally in perfect cube steps, I go over 1, up or down 1. I go over 2, up or down 8. Right? Those are the cube steps. So did this thing from my point of inflection go over 1 and move 1 vertically? Okay, so there's no vertical stretch or compression to it. That's it. That's it. It's done. Okay? That's how you tell the difference. What did it do over what it should have done? So say instead I had one like this. That was ugly, but you get the idea. If that's my point of inflection in the middle, it should have gone horizontally 1, vertically 1 from that point of inflection. I went 2, so I'd say a vertical stretch of 2. And that goes for every one of your parent functions. Parabolas are supposed to move by squares. Reciprocal functions are supposed to have that from my crosshairs over 1 up 1, because 1 divided by 1 is 1. Your radical functions, all of those, they're all going to follow a parent function rule, and this is how you tell your dilation. Okay, that was in the first 7 minutes of the next video that you're supposed to watch. Curious if anyone, especially those who are looking at ACT, actually listened to the ACT stuff. I saw that that was in there. The 1.5 video was me. I was yakking at last year's class about the ACT because it's about the same time of year. Yeah. So, like we're lining up almost exactly with what last year's was. And then below that, we're going to bring it back. Every now and then, you're going to see me do this where maybe we don't have to have 6 full things up here, and we can bring back a little bit of review. That review problem will be an absolute grab bag of anything we've ever talked about in this class or the ones below. I might randomly toss a geometry problem at you. Okay? But we review it right before we do it, right? The idea isn't to get you. The idea is to review stuff that you may have forgotten so it stays fresh in your head. Now, who remembers with combinatorics, when I ask a very specific question? Okay, how do I know it's combination, not permutation? Order does not matter. By the way, I have game club. I'm a dork. Deal with it. Okay? Right? No, these guys. Okay? I've been living in that world in my head since I was 12 and found a book at the library. Okay? You have 120 battle mechs and 240 vehicles of the 3rd Sky Rangers Regimental Combat Team. We won't talk about the infantry. They're putzes. What is the probability that a randomly selected honor guard of 12 units will include exactly 8 battle mechs? Well, sometimes you got to do randomly selected so that your honor guard has, like representation across the unit, depending what world they're from. Like, you don't want to do political favors or else people get weird. What is my total selection? How many total things do I have to choose from? 360. Okay, you are right, it is combinations. And how many total things am I selecting? Okay. Those 12 things are broken into how many categories? So that means I will have 2 combinations. Category 1, mechs. I have 120 mechs. I am choosing 8 of them. Vehicles, 240 vehicles. I am choosing
12 minus 8. 6. I don't know. I looked at it wrong.
It's all right, dude. It's all right. So, and just like we did 2 quizzes ago, make sure you actually write this part out, because it would really suck to do all the button pressing correctly or incorrectly and have nothing written down. Like, if all I see is a percent and nothing else, if that percent isn't dead on, then sorry, -5. Okay? So, devices over there, or in your bag or wherever. If I see a device while there's a test anywhere near you, I don't know, what's the number? I'm not pressing buttons. Frank is slow. Someone else press the buttons. I don't know if I trust him. Okay, you can go into math and over to probability.
Oh.
Or I can also get there. Alpha window brings up shortcut. No, I said alpha. Alpha window brings up your most commonly used ones, and that's on there too. Okay. All right. We've got room. Spread yourselves out, please.